Hello, good evening. Good evening, one.
Good evening, sir.
Yeah, we're going to start right away. Before I start, I need to introduce myself um, as instructor for this course. Most of you know me already. Am I correct? So, do I need to do elaborate introduction here? Um, my name is Ekba Daniel. I own a first degree in electrical and computer engineering from Federal University of Technology, MENA, here in Nigeria. And then a second degree in electronic engineering. I specialize in microprocessor from the University of Nigeria, Nsukka, and then a third degree at the University of Port Harcourt um, at the Institute of Engineering Technology, majored in ICT. I have a number of certifications cut across the IT, where you talk about networking, database, security, and then I also pioneer a number of academies for the university, from Oracle Academy to Cisco Academy, Alcatel. These are specialized academies tied to vendors that provide some IT services across the world. So I also represent the continent in the last cybersecurity competition where I came first in 2019 for the African continent. So I want to have your audience so that we can make this short class worthwhile. Um, I've asked you guys to do a number of installation. I know IT is not your field. I know you guys are more or less like immigrants coming from looking at the nursing background and then trying to adjust. But the good news here is that everything revolve ICT in this new normal. And so if you really want to catch up with the pace at which things are moving, then you just have to make ICT your friend. It makes your work smarter. It makes life interesting for you. Everything is converging on this platform. And so you're not doing this course just because you want to pass, but you're doing this course because you need to know it and communicate in this language. Uh, I've heard a number of people who talk about ICT, especially those people from the other divide in your own area, probably when they tend to explain certain concepts, some basic concepts, and they oftentimes get it wrongly. I don't think it's wise that way. And so what I have put together here actually is supposed to last for a week, but then I have a way I carry my students along, even though we have 2 days to go, but then there's much we could do. When you go back to the elements, I've attached a PowerPoint of about 17 chapters. That is for what we call the IT essentials. IT essentials is the basic, or is the fundamentals of information technology. This is coming from Cisco Systems. Cisco is an IT firm based in the US. It's a multi-billion-dollar firm. And what they are into is that they produce internet equipment. Like you are browsing the internet now. How are you able to browse from the comfort of your home, listening to me? All the devices that actually in that channel of communication is being produced by Cisco in a way. Of course, there are other vendors as well, or other companies that also um, produces the same ICT equipment. But Cisco, it seems to be the giant when it comes to internet equipment. They tend to lead in that area. And then they also measure in cybersecurity. So I want to say that at the end of those course, for your own set, I want to say that you guys end up having a certification in IT fundamentals. Um, I will employ that you guys should kind of cooperate. I wouldn't want to have this kind of excuses. complain here and there. What you just need to do is to brace it up, go through the chapters, read it at your own comfort after the class. I will give us 2 weeks alongside with the other courses you might be doing and see if we can be able to catch up. Those of you who can catch up, that's fine. You can write the exam. I will schedule a date for the exam after now. That's going to be online. That will be exclusive of this module. This module exam will come up on Tuesday. We're shifting it from Monday to Tuesday, so you're writing this exam on Tuesday. I've also talked to the next instructor or the next lecturer I'll be taking you to start on Wednesday. Reason being that there's a need for you guys to be able to do a lot. I asked you guys to do the installation for the EndNote, for the SPSS, and at the same time, you should have Excel, that's Microsoft Office, either 2016, 2010, I mean, one of the recent version, and so that we could do some little computations and see how we can format data, clean data, analyze data using these packages. For you, you can install a trial version for the period of this course. And then subsequently, if you feel it's necessary for you to have it, then you can subscribe. In other words, you can pay for one. It's online. All you just need to do is pay for the product key and then install it, or probably just insert it, and you're sure to have a full package. And if you don't want to do that, then you could just use the trial, and that will be fine. Nobody's going to make it compulsory for you to buy one, but then it's for your own take, so that you can practice and know what to do. So if you have complaint, what I would do is that we won't be doing anything around the area of Excel, EndNote. That will be in the next class. In the next class, I'm going to take you guys on 3 hours, each hour for each of these packages. So I would advise you don't miss the next class. If you do, that won't be a good one. But today we'll be looking at IT basis, fundamentals in ICT. I've listened to you guys complain here and there. I've read through some of the challenges some of you faced. But however, you guys are learning very fast. I must confess at this moment that this class is actually one of the best class so far in terms of catching up with kind of familiarizing yourself with ICT equipment, getting used to online kind of e-learning platform and all of that. You guys are doing very well. And then in terms of compliance, a lot of you are doing that. So kudos to your course rep and then personal efforts you've put into this. So I'm going to make it very straightforward, break it down as much as possible. If there are areas I have talked about you're not really clear, I'm going to give us the next, before I end the class, I'll give you 15 minutes to ask questions, and then we could iron out those questions, and then we'll move ahead. Then try to see that between now and Monday, you're able to install the 3 packages. Can we hear me, please? And kindly mute your mic, please, so that we don't interrupt the class. I just need your audience for this few hours, and then we'll be done. So you don't need to put on your mic. When it's time to ask questions, you can go ahead. So it's recorded, and after the class, I'll make the recording available on the LMS for us. So what we're going to actually look at here is we're going to describe the importance of computers in daily life, explain the difference between system software, application software, describe the 4 major types of operating systems. We're going to identify the tasks an operating system performs, start a computer, use an operating system and start an application, lock and shut down a computer. Basically, when you talk about information technology, one thing that comes to mind is the computer. The computer seems to be the hub, the center of attraction. And that is why you need to understand some basic concept about what we call the personal computer, the PC. Because if you don't have basic knowledge on this, it's going to mess you up in a way, because in terms of communication, you can't be able to communicate certain terms with people around, especially folks who actually familiarize themselves in this area. And so it will be necessary that you try as much as possible to upgrade yourself. So the aim of this module is to ensure that that communication issue in times to describe some of the IT equipment will be completely removed, such that you will come to terms with these terminologies. Um, if you're able to go through, I'm going to enroll all of you, like I said, for free on the Cisco Networking Academy. Reason being that that platform will guide you. I'll show you guys in the next class how you take your quizzes, take your chapters, assignment on that platform. Those of you who will be able to weather it through, you see that at the end of the day, you will have learned so much that, I mean, you can stand apart with some of your colleagues across the other globe. That's why sometimes I wish some of you could travel out to other countries, probably some of the developed countries. You also realize that when you talk to some nurses or you talk to some medical personnel, the way and manner they handle ICT, it's as if probably it was a major course in their primary school, secondary school, and all of that. So you just discover that these guys communicate ICT, do ICT, and then you'll be wondering if ICT is part of the nursing profession. In a way, it is, because most of the analysis, when your data is not clean, your data is not consistent, you're going to have errors. You can imagine taking the record of a patient, maybe height and all of that, weight, and then you key that wrongly, or probably you entered in Excel, and for any reason there's a bug and there's some issues, and those data actually are being used for one or two things. And then at the end of the day, the interpretation for that actually leads to some errors. You know what that clinical error will lead to. So what we're saying here is that the fact that you get to know how to use IT applications and devices will go a long way to help you to be able to maintain that consistency and remove anything error, because you guys deals with life. So it means that if you are using anything to interpret data or to make certain inferences and all of that, you need to make sure you're actually saying the right thing. You know what error could lead to when it comes to the medical field. So, and that's the reason why when you're using ICT equipment, you need to know how this thing functions. You need to know where some errors comes in, because I can imagine when you key in the right thing, and then for certain maybe hardware errors, some application error, sometimes you have some issues with your device. I could just share a simple example before to share a simple example when it comes to some of the inconsistency you can have when there's a hardware failure. Over the years, experiences I've gathered when it comes to hardware is, you can imagine you have a computer system. The computer system have a date. If you check your laptop or your phone now, you see on a daily basis, it gives you dates of maybe, I mean, the calendar date, and even your system gives you, some of you, if you say, what's this date? You check your phone, you check your laptop. I mean, that tells you that you begin to believe in the system. But I can tell you something here. There's what we call the CMOS, as a complementary metallic oxide semiconductor. It's, is a battery inside the computer system that helps to power the BIOS. In other words, the ROM device. I'm going to explain some of this concept as we go on. If that battery goes bad, I mean, it changes the date of your system, and then take your system back to probably the manufacturing date. And you can imagine the kind of inconsistency that will cause in some of the applications that might be running in your system. And so until that is fixed, you wouldn't know. And your system is going to work perfectly well. You boot it, you see the whole environment, but the date on that system would definitely not be correct. Even when you fix it right and you shut down the system and you restart the system, it will take it back to the manufacturer. So some of the challenges that comes with systems. So but that's the reason why a course like this will just help you take care of those fundamentals. Reason being that you might be good in using some applications, but you also need to have some underlying knowledge about this same platform you're using to carry out some of the job tasks. So this is what we're going to be looking at today, in addition to some other things I'm going to be discussing. So I'm going to do some detailed explanation. So I'm not just going to read from the slide, but I think I need your audience to really hear me out so that you can understand this concept very well. So let's go forward and see what all this is. So some of the words to know in the course of this module is application software, boot process, or called the buffer, command line interface, data, driver, embedded operating system, graphic user interface, hardware, icon, information processing cycle. When we talk about application software, usually if you look at your computer system, the good news here is that most of you have computers these days. I remember far back then, in the late 90s, early 2000, it's quite difficult for you to see people who own computers. Quite difficult. Sometimes you have to go to the lab, to use one. Some of us who study computer engineering far back then, I mean, we we occasionally visit the computer lab to tell you how precious it was then. But thank God for technology. Now we could clone systems and produce new computers in split of seconds. And you could see the first computer that was ever made in the early 50s. This computer system was more or less like as big as your room. If you have a 10 by 10 or 10 by 12 room, that was how big the first computer that was produced, was. And this same computer had a hardware. When we say hardware, the storage was so big to the point that you have about 5 people that have to move it into the system. You could see the desktop, and then I have a picture of it where I could share it in the next class. And then you could see them moving that hardware into that computer, and people need to travel around the world to that particular place to use the system. But today you have one at your comfort. Some of you have three, four. You have two laptops, you have desktops, you have your smartphones. That tells you how far technology has come. So let's begin to look at some of the words that actually are necessary here. Application software. The computer hardware is the mainframe which you use, and you can actually interact with the hardware of your computer. You need certain software that enable you to interact with your computer. If you shut down your computer system and try to open up the keyboard and try to find out where is this thing that is displaying on my screen, you're not going to see anything. Rather, what you see a circuit board. That circuit board, we call it the motherboard. That is what house all the components of the computer. In that motherboard, we have what we call um, the processor, we have what we call the RAM, the ROM, and all of that. And they work together to see that you have this display, which is quite interesting. But what happened behind the scene, oftentimes we don't want to know. But what we want to see is that is my computer working? Can I type what I want to type? Can I send my email? That's exactly what the user experience uh, is all about. But then, I mean, what happens behind the scene actually is important because that is where you can trace some of the challenges you might be facing using the device. So before you call a technician to fix your system, you also need to have some basic troubleshooting knowledge such that you could say, oh, this could be this fault, this fault, based on what I am taught, based on what I've studied, based on some of the search I have made. And then once you do all of that, it helps you to be able to narrow down the problem. So that is why it is necessary for us to really get this knowledge right. So the application software here we're referring to is that um, in the hierarchy of the system, that's a personal computer, you have the hardware. And from the hardware, we have what we call the operating system. So the computer hardware is the physical part of the computer. You can see the keyboard, the mouse, I mean, the computer motherboard that I mentioned earlier, and even your screen. These are actually hardware. Next to it is the operating system. The operating system is what you have before. Some of you, when you boot your system, when we say boot is when you power it on. So that's called the boot process. So when you boot your system, you see something loading. Some of you have what we call Windows 10, Windows 8. If you look at it critically, now what you see there is the operating system. So the next after the operating system is called the application software. I've asked you folks to install EndNote. I've asked you to install Microsoft Office 2010, 2016, where you get your Excel. I've also asked you to install XPSS. These are what we call application software. So if you're asked what is an application software is like a third-party software that you installed on your system to be able to carry out certain activities. So the next time you'll be hearing, oh, what kind of application software do you use? What kind of application software do you have in your system? What the person is simply asking is that, oh, what do you use? Do you have Microsoft? Do you have Corel Draw? Do you have SPSS? Do you have, Excel? Those are application software. And when somebody asks you what is operating system, the person is asking you, are you using Windows 10? Are you using Windows 8? Are you using Windows 7? You need to know how to differentiate between these three: hardware, operating system, and application software. So I've given us example of what the hardware is. I've given us example of what the operating system is, and I've also given an example of what the application software is. Now we're looking at what is boot process. When you power on your computer system, the first line of call is that the system goes through a process which you call the post. The post is POST. That's what we call the power on self-test. The power on self-test is the process that happens before your operating system start loading. The computer is more or less designed in such a way that a signal will flow from the processor to all the devices, and then finally your operating system start loading. And so there's what we call the BIOS. The BIOS is housed in the ROM. The BIOS will start loading. This is a pre-installed instruction set from the manufacturer. And then once it starts loading, it calls up the operating system. So before your operating system start loading, that power on self-test process must be completed. And that's the reason why when you power on your system, oftentimes you begin to see you see a black screen, you see some information loading, you see your RAM size, you begin to see some numbers and all of that. And some of the information you see there, you're not really interested. You wait until when that is over, and then you start seeing welcome to Windows operating system, or you see your Windows operating system loading. That is what you're familiar with. So that black screen that shows up at first is the process of the post. And that post process is where the computer begins to check, oh, is the mouse there? There's mouse present. What's the RAM? The RAM is there. It check everything, all the peripheral devices, and be sure that they are all intact before it start loading the operating system. So the post process must be completed. Most of you who use desktop oftentimes will agree with me. Even laptops, you see that sometimes it will be powering on, sometimes you get to a point, say press F1 to continue. In some cases, it tell you, okay, CPU fan not working. It tell you sometimes uh, system shut down due to maybe overheating or something. Now that tells you that the post is not completed at such time. And if you don't check those errors, gradually it might lead to certain problem. And so post is that first stage that the computer system has to go through once you power it on, once you before your operating system start loading. And then the buffer, when you hear buffer actually has to do with memory. Everything is memory. Look at the way we humans interact. Um, the computer world is more or less taking the place of humans when it comes to communication. So you and I, when we meet physically, we talk to each other. In other words, we share information. But we also have computers sharing information. And that's why I could talk to you through a system. I could share a slide with you. So the question is that what keeps this information is the buffer. And what is a buffer? Buffer are memories. Memories from like your RAM, random access memory, which you know. Some of you haven't seen one before. I'll show you the picture of what a RAM looks like. And then you have the ROM. So what we're saying is that the buffer now is the memory where these information are temporarily kept. And your RAM, which is an example of a buffer, keeps information on a temporary occasion. until when you save it to your permanent storage device, which is called your hard drive. And so there's a difference between your hard drive and your RAM. And so the RAM is an example of a buffer. And how do you tell when you use your RAM? When you open up an Excel spreadsheet, or you open up the Microsoft Word, or just like you power on your system and I could share my screen with you and you could see the information that is shared, what keeps your system housing this information as we go is the RAM. So the RAM temporarily keeps your Word, your Excel open for you to do things. And oftentimes, if you don't save your work properly, and probably you have some kind of power surge or some power outage, and probably your battery system, laptop battery system, aren't working well, you just got the system will just shut down, and all that you have typed for the whole day might just disappeared, except you have actually enabled what we call autosave. And autosave is still a function, in other words, of the RAM in relation with your hard drive. And so what we're saying is that you will lose a whole lot of information if they are not saved in the permanent storage, because that is what the RAM is. The RAM is more or less a running activity. So all your activities that run at the background when you power your system, they run there in your RAM. And so that means the RAM is important when one is trying to procure a computer. Some of you ask somebody, oh, when I want to buy a computer, what should I look out for? Some of us just go to the market. You see two computers that look alike. One is 100,000, one is 600,000. You say, what's the difference? They say it's the processor. They call some names for you and you just get confused. And you say, are they not doing the same thing? They say, yes. You pick the one of 100,000 naira. Without actually knowing the reason why there's one that is 100,000 and one that is 600,000, even up to a million. There's laptop as we speak now in Nigeria that goes for as close as 1 million naira. But some of you will be wondering, why will I have to buy a laptop of 1 million? The question is that what do you want to do with the system? And secondly, what are the specifications of the system? So I'll also talk about the specification, the concluding part of this course, to help us when we want to procure a computer, to also help us when we're discussing in the place and somebody asks a question, how do I know the right specification of system to buy? I mean, this class today will help you to be able to ascertain to such kind of questions and be able to answer such questions, and then help yourself and help the people around you. And then the command line interface. The command line interface, this is more or less incorporated into some of the things you do. Like for instance, when you're within XPSS, there's some command line part you could use. There's certain applications that require using command line. Command line are like tasks, some argument that you try to do when you're trying to create a query or you're trying to search for some files and folders. Most of us don't use a command line interface. The command line interface actually is the other side of the interface of the computer where you key in certain commands to actually fetch certain information. I'll show us how your screen looks like when you're using the command line interface. And then there's what we call data. So what goes through your system usually is data. The computer system processes data. And what processes data is the processor. The processor helps you to process data. So when you type anything on your keyboard, they are going as streams of what we call bits. And these bits are converted into what we call packets. And from packet, they encapsulate into what we call data. And so when you, next time you begin to press your keyboard, just know that you're sending in some electrical signals that have to go through the processor, and the processor will interpret it, package it into packets, and then it gets encapsulated into what we call data. So what you see on your screen is data. And this data, when it's processed, becomes an information. So you could see here that information is a processed data. And then you can also see that the data itself is when you break down the information into bits of signals. And so the computer system processes as data, but when you and I are talking, we'll call it information. And so that's for data. And then the driver, what we hear, oh, have you installed the driver? Have you installed When we call driver are like third-party software that you install to enable you to use certain devices. Sometimes you install an application that said no, you need to install a driver before this will work. Some of you agree with me that when you want to use your system maybe with a projector, you plug it, it's not displaying. They'll tell you you need to install a USB to HDMI or USB to VGA drive, and then you begin to search for the drive on the internet. And then once you install it, I mean, bravo! Before you know it, starts saying working. I mean, that's what a driver is. So a driver is like a software and applications that you need to install to enable you use certain devices or have certain application works for you. So the total called the embedded operating system. I've explained what operating system is, but embedded system is when an operating system is embedded in a device. Um, for instance, some of you have a microwave at home using, and your microwave has a display. You power it on, you see certain things loading. Now that is embedded. It's embedded inside a device, and then you have it incorporated in that microwave. Some of us have um, smart AC. Some people have a smart um, refrigerator, and this smart refrigerator, when you power it on, you see it loading certain things on the screen. That is an embedded operating system. Now, what we call the graphical user interface. The graphical user interface is actually what, when, like, for instance, when you power on your system and you open your Microsoft Word, you open up certain applications and you will click from one point to the other. For instance, here am I showing you, uh, sharing with you this information. I could actually go to insert on this word, go to page layout, I could go to reference and all of that. What we're saying, this is GUI. This is graphical user interface. So most of the times when you use certain applications that actually makes it easier for you, that is what we call the GUI. Prior, you see, Microsoft wasn't the first um, operating system. The operating system we used to have in the days of DOS, actually you use command line. So people never find it funny. If you ask folks who were using computers, some of you are probably, if you ask some friends of yours who have used computer in the early 90s and early 2000s, they will tell you, oh boy, we're using DOS. DOS was so difficult. You want to search for a folder, you go to the command line, you put, you type C, column this, backslash, that. You need to go through some rigorous processes just to open up a file. You can imagine how complicated it was then. But then when Microsoft came, they make things graphical. They just make you click, 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 open, click, 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 open, and it becomes friendly. And so that's why everybody jump into Microsoft, and that's where Bill Gates actually made his fortune from, because people now find it quite, interactive, find it quite interesting. If to the days of the DOS, I don't think all of you will just jump in and begin to see my screen. You need to carry out certain commands. So that is exactly what the graphical user interface is. So when you find out that anytime you have an application that you could just click, 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 click and get your result, you say, oh, that's a graphical user interface you have there. I mean, this application is of graphical user interface. But when it requires you key in some command, making some argument, I mean, keying in certain codes for you be able to get the information you're searching for, then automatically you're using the command line interface. So there's some differences between a GUI and the command line. So the next time I'll say, oh, that application you're using, is it of GUI? What I'm saying is that, is it of graphical user interface? Is it interactive? Is it easy to click, click, click and get some result? That's what we call the GUI. So I think henceforth you'll be able to use that term without issue. And so the hardware, I've explained what the hardware is. An icon. Icon is what you see on your desktop. You can see the desktop of your file, the desktop on your desktop. You can see some files and folders and all of that, we call them icon. You could also have the icon for internet. You could have the icon for your battery on your laptop, on your phone. So you could tell when the battery is low, when the battery is fully charged. So those are things we refer to as icon. Then information processing cycle is a process which the information is being processed. In other words, when you key in an input signal, you have the processor. So the processor processes the information and gives you certain output. Now I'm going to break here a little and ask a question under this particular word, information, another word, phrase, information processing cycle. What do you call that box you have by the side of your monitor? I'm not talking about the laptop now. I'm talking about your desktop computer. Your desktop computer is not of a laptop. It has a screen and then it has a box that is attached to it. So what do you call that box? I want to get some answers from you before I go further. I hope you guys are hearing me. I hope I'm not talking to myself. Hello?
Yes, sir, we are hearing
We are hearing.
We are hearing you, sir.
Oh, lovely. So what do you call that box that is attached to your desktop, your monitor?
CPU. CPU.
Okay.
It's CPU.
Oh, it's CPU. I heard the voice of a baby. Or is that an adult talking? Okay. CPU. If you say CPU on the screen, raise your hand. If you said CPU on the screen, raise your hand. I'm seeing Obioma, Miriam. Are you going to ask a question or you're raising your hand based on what I just said? If you said CPU,
I'm raising my hand based on saying CPU.
Oh, beautiful. If you say CPU, please raise your hand. I want to take a screenshot. If you say CPU, raise your hand. Oh, lovely. Please, you just have 1 minute to quickly do this. This is a quiz I'm giving you now. So if you don't do this, that means you're not following. I'm going to screenshot it and then there will be marked for it. Okay, so I'm giving you 30 seconds, those of you who are yet to make a decision on this. If you think it's CPU, raise your hand up. And if you think it's not CPU as well, you can put down your hand. I'm still waiting for, so you have 10 seconds to make a choice. Okay. Lovely. 10 seconds you have. You have 5 seconds. You have 3 seconds. You have 2 seconds. You have 2 seconds. You have 1 second. I'm going to screenshot this. Those of you who are not even participating. And if you're probably, you just on your system and decide to take a walk outside, then you lost this. And then finally, we go. Okay. So let me just quickly screenshot. You need to check your network very well. It's like the internet is fluctuating, so I can't hear you clearly. Or others, can you hear her well? Hello, can we hear?
No, sir. No, sir. It's breaking. It's breaking.
No, sir. No, sir. We can't hear, please.
Okay, I think if you can, you that is asking the question, please, you need to check your internet. We can't hear you clearly. Okay.
She said, "What is the question?"
So you could use the chat to ask the question.
She said, "What is the question, sir?"
The question I asked is this: you agree with me that you have a smartphone? Some of you have what we call laptops. You know what a laptop, a computer laptop looks like. You also have what we call desktop, palm top. The desktop you have is the one that have a monitor and have a box attached to it. So the box could be either a tower box, which is a long one, or could be a flat one, which is actually what we refer to as the desktop itself. And so that box that is attached to that monitor, what is the name of that box? What do you call it?
Central Processing Unit, CPU.
Good. She said
CPU.
Good. So if you call it CPU, I say raise your hand up.
Raise my hand.
Okay.
So people like
I think it's system unit.
I've raised
if you're of the CPU, you raise your hand up. So okay, lovely. So Iagba Stella is not raising her hand. Charity is not raising her hand.
I think it's system unit. I have a contrary view.
Oh, please, hold on. So I have okay, I have Pauline.
Charity Zan is up. Oh, Charity Tula Zan is up.
I have Charity's
hand is up. Oh.
Wokoma's hand is up. Please, sir.
Please. Let's have one house. I'm the one talking here. Just hold on. I'm seeing your hands. If your hand is not up, I know. I'm just calling names of people whose hands are not up. eBay.
Okay, sir.
Welcome. So once you hear your name, it means your hand is not up. And Jacqueline, your hand is not up. And who is tablet 12? Please, we have told you to change this and put your real name, so we'll know who we're dealing with here. Okay. So these folks' hands are not up, but the rest of us who have raised our hands. That's interesting. So I could see here that 80% of the class. Please mute your mic. Please mute your mic. Mute your mic. Okay.
My hand is up, sir.
Everybody mute your mic, please. Mute your mic. So I have about 70% of the class saying CPU. And then somebody said system unit. Who said system unit? Who said system unit?
Iagba.
Okay, Stella Iagba. Okay. Is she there? She's not there again. So she logged out immediately. Okay. So like I said, 80% of you said
I'm here, sir.
And then one person said system unit. The rest of us who didn't raise our hand, what are we calling this box? So we are neutral. So we don't even earn any mark for this. Okay, that's nice. So we're just they are just there and they're not part of the class. Okay. If you say the system unit, raise your hand. Those of you who say CPU, drop your hand. Those of you who said, and she said system unit. So if you support that fact that the system, you raise your hand. Okay, interesting. Now, let me say this categorically for this class. When you say system unit, you're very correct. When you said CPU, you're wrong. The box is not CPU. The CPU is a central processing unit that is actually inside the motherboard. I'm going to show us a picture.
Wow! Happy.
So I have, over the years, I've seen textbooks, I've seen authors describing that box as CPU. But then it's actually wrong. And that's the reason why I would advise that you take up this course. I'm going to enroll you. At the end of this course, I'm going to send us a link on the platform, on your WhatsApp platform. You click on that link, register for it, put your name, first name, second name, your email address. Then I'll enroll you into the Cisco class, and then activate the assessment for you to start taking. And then before in the next class, I'll tell you when you're going to have a final quiz on that class. And then that will take about 15 marks for my own continuous assessment. And then, like I said, once you're done with that, you have a certificate from Cisco. And then you can keep that certificate. I mean, you can rest assured that you can present any day, anytime, because it's an international certification. And then you'll be able to let people know that, yes, you have that basic knowledge when it comes to IT. Because I want to believe that a handful of us don't even have a certification to show for when it comes to information technology. So I think that will help us. So that will help validate our knowledge at the end of this course. So the information process, so that device is called a system unit or a computer case. It is not a CPU. It is not a CPU. You can hear me out loud. The CPU is a component on the inside that box. And so you call it a unit, a system unit, because it could be empty. So you can imagine when you open it up and it's empty. So what do you say? You still call it a processor? Where is the processor? The processor must be seen. And so I'm going to show us what a processor looks like. It's quite small, and it's the brain of the computer. So when we talk about information processing cycle, the processor helps us to process the information. Okay. And so we will move to some words: multi-user operating system. We have a multi-user operating system when we can have an operating system that enables multi-users to connect to. We have what we call the open source software. Open source software is software that are free, open for you to use. And you could also make some changes at the back end and customize it to suit what you want. So you'll be hearing open source, open source. Open source are free. They are a group of programmers who have come together to make this free so that could make life easier for people. And then I've explained the operating system, random access memory, I've said it, server operating system. The server operating system is that computer system as well that respond to your request each time you type in, maybe for instance, when you want to check your Facebook, you go to www.facebook.com. That Facebook you go to is a computer server. Those actually somewhere in the US, and then if it is shut down, you can access your Facebook account. But these are like so what we're saying is that that particular computer system, which everybody connects to access their Facebook information or probably do one or two things online, is what we call the server. And so the server is that computer system that responds to requests. So your own laptop or your own computer that you use to actually query that that link, or what we call the website, or on your URL, it's actually doing what we call the client, or making a request. And then the response you get is what we call the server. So it's coming from a server system. A software is that intangible application that run on your system. I mean, you could neither touch. It's more or less complete instruction set that guides how the system functions. And then the swapping here is actually has to do with the way and manner in which the system can switch from one model of device to the other. And then we have the system software. And so remember I told us about application software. The system software is also another word for operating system. So if I asked you what kind of system software do you use, what I'm asking you, what is your operating system? So please look out for such word as you go. So in case you're doing your multiple choice and something comes up like that, you should be able to know. The utility program, and utility program are still application program that you use, and then virtual memory are memories that run on your RAM, still virtual in the sense that it's actually can be lost at any point in time. Understanding the importance of computer science, computers. So computers are everywhere. Computers are used in cell phone, in ATMs, in your home, thermostat, and in your car, cruise control. And so we have the computer system embedded in some different formats. So you could call it the embedded system. And that's the reason why everything is going smart these days, because we are in the fourth industrial revolution where everything is becoming interactive on the internet. And some of you heard smart fan, smart AC, you have a smart TV. So when you hear all this smart thing, these are devices that begin to have embedded computer system in them. So they have processor, they have RAM. I mean, they store information and all of that. And so that shows that everything is going smart. So computers assist you in most parts of your daily life and play a central role in worldwide communication, entertainment, education, commerce, and other business activities. So computers have been around since the late 1940s. Then they were massive, special purpose machine with names such as UNIVAC and ENIAC, and were designed for use by military and government. So far back then, that is the trend. of the computer systems. But then let's move further to see what it's all about. So a computer, if you want to define a computer, you define it as an electronic device that receives data, processes data, store data, and produce a result. And so a computer is that electronic device. So any electronic device that can take in data, process, and gives an output is called a computer. So it is not only the one you have in front of you call a computer. As long as it can take in, process, and gives an output, it's a computer. Is a computer device on its own. So data is a collection of raw, unprocessed facts, including your text, numbers, sound, images, and video. Now I'm going to pause here and ask this question under this lesson 1. What is, when I say, when I type 80, what does that represent? When I type 80, what does that represent? Hello?
Hello,
Speak.
sir.
I just type 80.
In words or in figure?
Type 80. If I type 80, what does that represent?
It's a raw data.
If I say height is 80, what is that? If I say height is 80, what is that? When I say, God bless you, information. So data is that raw unprocessed fact, which we said including text, numbers. So when you see numbers like 10, 20, that's data. But when you say height is equal 80, it's an information you have passed. So data is unprocessed fact, and information is processed data. Data is unorganized, information is organized. Data is insignificant, information is what? Significant. Data cannot be used to make informed decision, but information can be used to make what? Informed decision. True or false? Hello?
True, sir.
Hello, sir.
We use data. So we could say data can help us make decision, but we could say information helps us to make what? Decision. So these are differences, some of the differences you point out between data and information. And so that the next time you're asked to differentiate between the two, you should be able to differentiate them. Okay?
Sir, please come again. Sorry. Difference between the data and the information.
We just pointed out here that data is collection of raw processed fact. So
yes,
data could be text, could be numbers, sound, could be images, and video. I could just draw an image, but the image could make no sense. Isn't it so? But when if I put a boy, that is what? An information. It tells you that that image is saying this is a boy, right?
Yes.
But you could have the image, and the image could make no sense until an information is attached to it, or some kind of explanation is attached to that. So what we're saying is that we said data is raw and is unprocessed. You can say data is raw information, and you can say information is processed data. And then you could also say data is insignificant. The information is what? Significant. You can say data is unorganized. Data is unorganized. That's the reason why you go to the field and you say, let me go and gather data. When you gather data, what do you do with it? At that point in time, that data is organized. When you now analyze the data, you now simulate the data. You now have certain information you want to explain. So you now use probably SPSS, you now use Excel to analyze the data, and then now put it in a graphical form. And then when you put it in the graphical form, people can now understand what the data is doing, true or false. So when you go to the field and you gather data and you have not organized that data or analyzed that data is still what? Unorganized. But when it is organized, it is what? Information. And data itself, like I said, also as one of the differences, I said data cannot be used to make informed decision. When we say informed decision, is that it makes no sense. Data makes no sense. But information can be used to make what? Informed decision. So we could say that the height of an average student in a class or in class A is 1.6 meters. That is what an informed decision. Is that okay? So in other words, if somebody wants to probably design or come up with some material that students or folks or pupils will wear, the person have an idea of the height, the average height of a student in that or pupil in that class. So you can use it to make what? Informed decision. So that is what information helps you to achieve. And then you can use it to what? To make some, to solve problems. So you can use information to solve what? Problems. So, but then when you just have data on its own, data cannot be used to solve what? Problems. Are we together? Okay.
Yes, sir.
Yes,
Yes,
Yes, sir.
we talk about the hardware, the software, talk about the input, process, and output, and we differentiated between data and information. And from the picture here, you can see when you impute, when you making some, you be clicking your mouse or you're holding certain devices that you could key in the keyboard, key on the keyboard. You can see the process data. You could see your output here, probably through your IP phones or through your printer. And then you could see the store. So here is a typical architecture of how the computer system works. It goes with an input, process, and then output, and then store. So a typical computer system should be able to take in input signal, should be able to process that signal, and while it's processing, should be able to store that signal or information, and then be able to give what? An output, and the output is what? An information. So what is going in is data, what is processed is data, what is stored is data, and what is given out at the output is what? Information. Okay, and so let's look at computer literacy. So to be computer literate means when somebody say, "Oh, you're computer literate," what does a person mean? That you can use today's computer efficiently to enhance your life and the lives of those around you. The very moment you cannot be able to use computer efficiently and enhance life around you, or probably explain certain concepts, or let people be able to know what to do around you, that is, you're not computer literate. So at least right now, you begin to assess yourself and tell yourself, where am I? That's the reason why I said there's a need for us to pick up that and class and see that we come apart with this. So computer literacy also means you understand a wide range of information about current technology and how it is used to solve problems. And then a digital divide is an economic gap between those who are computer literate and have access to computer technology and those who do. So primarily, the first two here is to tell you when you are actually computer literate. And when you hear the term digital divide, it's that gap, I mean, between the literate and those that are not literate when it comes to the usage of information technology. Types of software, we've also mentioned this, the graphical user part, and talk about the system software. And so you could see here is a typical Windows 8 or Windows, yeah. And then you could see the start. You could see that this is graphical in the sense that there are icons that is used to depict certain information there. And then types of software, we've explained the command line. So this is a typical um, diagram of how the command line looks like. So you will see here that when you type dir, that's a directory. The directory you're trying to get into the C drive of your system. And when you follow this pattern, I mean, it's not friendly. So you can see the difference between when this is graphical user interface and then this is command line. So when you're key in, so some of you will have actually come across things like it on your system. And most of you, when you see something like this, you're scared. Don't be scared, please. It's still another interacting interface in the computer system. So we explained this concept of system software and application software already. So I'm going to actually make the slide available on the LMS for us. And then types of software. And so quickly, we'll go straight to the types of operating system. That actually I've explained. I told you about the Windows 7, Windows 10, and that's for Windows. But we also have Linux. Linux, you've heard of Linux operating system. We also have Macintosh, which is from Apple. And so oftentimes it's that you're using Android. Android is the one you have on some of your smartphones. Those of you who are using Android devices. And those of you who are using Apple, you have the Mac as the OS as a different operating system altogether, which is Macintosh. And then so you can see the difference between these three. So you have Windows, you have Android, you have Linux. So these are what we refer to as operating systems. So not necessarily only Windows or the one from Microsoft, but these other ones are also operating system. But the most friendly that most people use oftentimes is Microsoft because it seems to be more. And then even Android too have graphical user interface. And so you could see that personal computer operating system or desktop operating system are installed on a single computer and are called single user operating system because one user interacts with the operating system at a time. So you could have the multi type and you can have the that's what it's called personal or your desktop systems. So when you hear PC, it's personal computer. Those of you who will make it home use, or everybody will be hitting the keyboard, hitting this. I tell you, such system won't last. I mean, to back up in no distant time. So it's called personal, so that one person uses it at a time. There are multitasking operating system, which means with more than one program at a time. So most of the systems we have are actually multitasking. So sometimes I can say, I can multitask my system. That means you could do several activities at the same time on the system. The three most popular personal computer operating system are Windows, Mac OS, which is for Apple, and Linux. For the Linux, for Windows, we have said it here that you have Windows 7, Windows 8, Windows 9, Windows 10. Way back, we have Windows XP, Windows 95, Windows 98. I mean, those are the Windows generations of operating system. And so we have the Mac OS, and then we have Linux. For Linux, we have different type. You have Linux that has to do with Red Hat. We have the one we call, so Red Hat is an example of Linux. We have CentOS. We have CentOS as also the type of Linux. You also have what we call Ubuntu. Ubuntu is another type of Linux operating system, but Ubuntu is an open source. So most of the Linux operating systems are open source. That means they are free. You don't pay for them. Windows, you have to pay. So some of us who format our system with pirated operating system. But then if you're to get genuine operating system, it's quite expensive. It goes for about 20 to 30,000 naira to get an operating system. And that's how expensive it is. And most systems are imported into Nigeria oftentimes are without operating system because it comes cheaper. Okay, so explain that to us. And then I've also explained those types of operating system. So you can also go through that here. We have a mobile operating system. The mobile operating system is designed for small handheld or computing device like on your phone. And then you have a smartphone, which is mostly the phone that you can actually do video. You could do more or less what we call a unified device, where you could have all these features all running on the same phone. So it's actually smart in the sense that you can browse it and do stuff with it. And remember, before now, most of the phone we used to have those days, you couldn't browse with them. Those were normal Mac operating system, but now you have smartphone, and then you have tablet. Okay, so these are types of operating system. Still, like I told us, the most familiar one, or the ones you can remember for this course is make sure you remember your Windows, your Mac OS, remember your Android, and remember your Linux. Once you can remember this, you're good with the different types of operating system. So I will go straight to the task of the operating system. Like we said earlier, has to do with the control of the time you turn on the power to the time you turn it off. So the time you turn on your system to the time you turn it off, you're actually using the operating system. So when you turn it on, like I said, the first thing that loads is the BIOS will start loading, and then that process is called the post. And once that post is completed, then your operating system loads. But all through the activity, you're using your operating system, and then until the time when you shut down the system. So it takes care of technical tasks such as start, up steps, manage your memory, processing input and output, controlling your hardware, and ending the computer section. That's what the operating system helps you do. And so this is a boot process to show what I explained on the um, uh, power on your computer system. And so managing the memory, if you can hear me clearly, managing the computer memory, so you're still under the operating system, you can manage your computer memory here. In other words, you can actually share your memory on the system. You can fragment your storage and actually outportion certain part of the storage for certain activity. And a resource is any component the system requires to do work. So if you have any component the system requires to carry out certain activities, is called resource. For instance, your memory is also a resource on its own. And even the information you share is also a resource. But when we talk about the memory, like being a resource, for instance, if you plug in a VGA or a HDMI cable, some of us will ask what is VGA. If you have a projector, that cable of the projector that has a port, some tiny port that you need to plug to your computer, your monitor, or your desktop, it's actually what we call the VGA. But the one that have just the USB-like kind of shape that comes from maybe your TV to your home theater is referred to as the HDMI. So the HDMI is the modern connecting device. But each time you plug it to your system, it takes certain parts of the memory. It takes resources, memory resources, for you to be able to display information on your screen. So if you have a system that, for instance, is 8 gig RAM memory, by the time you plug mouse, you plug keyboard, you plug your hard drive, probably you plug an external hard drive or a flash drive, and then you plug a projector like a printer at the same time. It's got that 8 gig memory. If you go to check it at that point in time, it will have dropped to 7 point something, because there's a memory, there's what we call memory resource that's been shared. So your RAM keeps sharing those resources to be able to make up so that those devices will work. And that's the reason why when you have a system, memory is important as part of the specification when you are talking about system specification. I've explained RAM to us, and I've told us what RAM does. I've also explained to us how memory have been managed. And I said this memory can be managed in terms of that's your memory, your RAM memory, can be managed and to share, so you can share it across other devices as well. So let's go straight to, I believe we could concentrate to summary of this lesson. So a computer is an electronic device that receives data that we've explained. We've also explained what the computer includes as a physical equipment, such as a wire and a circuit. So all those things you see physically around your computer, it's actually what makes up the computer. And still, keep up with changes in computer technology, you need to be computer literate, and which means that you can use today's computer hardware and software efficiently. And for us to be computer literate, that's the reason why I'm going to enroll us into that platform. So if you think you're already computer literate, that is where you exercise your knowledge and be able to answer some of those quizzes and see what your score. So in the next class, we're going to have a quiz. We're going to have quiz subject to what we have learned. So the first 15 minutes, you answer my quiz, and then thereafter we'll move on to the class. Or if we don't mind, I can also put a quiz up on the LMS.
Yes, sir.
And for us to do our own spare time. But it will be good to catch you early by putting
Yes.
then you do the quiz, then we'll continue the class. That's the way to get to know. If not, some of you go and search and search and search and search and tell me you scored 10 over 10. So we need to check you out maybe before we start the next class, just to be sure that you actually learned something from this class. And the summary is that you interact with software through its user interface, which will refer to either command line or the GUI. And I've told you the GUI is the one that you could see the icon and everything, like your Windows operating system. It's a typical GUI. And then also we did talk about computers run two main types of softwares. We said system software and application software. And the system software I said is your operating system, which could be Linux, which could be Mac OS, which could be Windows. And when we say Windows, it could be Windows 10, 7, could be Windows 8, could be Windows XP, could be Windows 95. Then if it's Linux, it could be Ubuntu, it could be Red Hat, it could be CentOS and all of that. So that's what we refer to as system software. And then we talked about application software. And I said example of application software is like the EndNote I asked you to install, like the SPSS. These are application software. So when I ask you, oh, how many application software do you have running on your system? You should be able to know. Or what you have there is an application software, you should be able to tell. I mean, that helps you to validate your knowledge for when it comes to system software and what we call application software. So system software, like I said, runs on the computer and includes the operating system and utility programs. Those are system software. And then we also define operating system as relate the resources and activities on the computer. Application software is software you use to carry out your tasks, which we have mentioned, the Windows and Linux and all of that. And then we've also talked about personal computer, which run on a personal PC. And we said your personal computer at home is not for everybody to hit the keyboard at the same time. And then your mobile operating system, which you also said is a system operating system that runs your mobile devices like your Android. It's actually mobile operating system. And then we could have embedded operating system, like the one I said is incorporated into some of your smart devices at home. And you could see that from your microwave, you could see that from your smart refrigerator, you see that from your smart fan and all of that. So those comes with embedded operating system. And then we talk about single user, single task, multitasking. And you know what it is when it's single, when it's multitasking, when you could do so many things on your system at the same time is multi-taxing. I've also explained to Rose what the boot process is, in addition to tell you what BIOS is, which is boot input output system. And I explained to Rose what the post does in the boot up of your computer system. And I said after the post comes the operating system loading. And I explained to us what post is all about. So I want to believe we don't have issues with that. And the resources an operating system manages also include RAM. And I told us how that can be shared and how you connect peripheral devices to it. And it takes part of the memory. So RAM is crucial when it comes to system usage. And the higher the RAM, the better the performance of the system. And so to keep your computer running smoothly, the operating system set a sequence of processing input and output tasks, which happens all the time, and uses buffer, which are part of memory or storage, where the data waits until it can be transferred to a device. I've told us, so the buffer is like that temporary memory that keeps data waiting. For instance, when you want to print, so those of you who print oftentimes, when you send a work to your printer, it goes to stay in the buffer. And from the buffer, which is a temporary memory, and that buffer actually sometimes is a particular type of RAM, and then it goes to the printer's app. That's the reason why sometimes even when you shut down your system and you just power you on your system, you see your printer printing, you'll be wondering, where is this work coming from again? You know, you start screaming, where is this one coming from? If you don't quickly stop the printing process, you just end up having series of printed work. That's because the buffer still keep that information, and the next time you power on the device, it starts printing. So you need to clear that buffer. And to control the hardware resources, we've also explained that also. We've also talked about, like we talked about the PC. And then in addition to this, I also need to tell us this specifically, that when you are asked to get um, a specification of a system, 4 things should come to your mind. What is the processor size? What is the RAM size? What is the operating system? And then you also need to find out.
I'm not here. We are not hearing you very well. Oh.
Hello, can we hear me, please? Hello.
Yes.
It's breaking.
Okay, my voice is breaking, or your own voice is breaking. Can we hear me, please?
Yes, sir. Yes, sir.
Okay.
Yes.
If you can hear me, raise your hand up. If you can hear me clearly, raise your hand up. Let me now have a statistic. Raise your hand up. Let me now have a statistic. Some of you need your that it doesn't echo. If you can hear me, you don't need to talk. Just raise your hand. Thank you. Okay. Please, if you can hear me, raise your hand up.
I can hear you, but you're too fast, sir.
If you can hear me, raise your hand up. Okay. So if these numbers can hear me, I mean 70%, 80% of the class is hearing me. Okay. So when I finish, you can ask questions. If you don't have it, and then I can make certain clarification. And then we'll move on from there. So I was going to talk about system specification.
Sorry, not that we are not hearing you, but the line is breaking. That's my problem. It's breaking.
Okay, this class is recorded, and I'll make the recording.
At intervals.
Excuse me, sir. The line is breaking, and you are fast. You're a bit fast.
At intervals, it's breaking. Not that I'm not hearing. I'm hearing good part of it, but it's breaking at intervals.
When it's breaking, two things happen here. It's either from your end, your network, your internet network signal is not strong enough, or from my own end. And so we also need to find out from others. Please, how many of you can hear me clearly? How many of you can hear me clearly? I'm going to show you using the command line how you could test if your system internet is okay. I mean, maybe before you write your exam, you want to test the speed of your internet. I'm going to show us using the command line so that we can all practice that. You want those of you that are using your laptop. So if you can hear me clearly, can you just speak out and say, okay, I heard you clearly from the beginning of the class and to this very moment.
I heard you clearly, sir.
Okay, fine. So if those of you are saying you heard me clearly from the beginning, that tells you
clearly.
Oh, great. So if you've heard me clearly, that means from my own end, the internet is not that bad. But if you weren't hearing me clearly, probably you have a poor internet at your own end. It might not be your fault. It's just the network, the network you're using that might not really be helping you out. So there's a need for you to check. So I'm going to quickly.
Hello, doctor. Please.
Hello, sir. You are becoming fast too.
I'm not teaching. I'm only just sharing opinion here.
Okay.
Please, if it's possible to also upload it, so I can also get the record. Apart from being
that's why I said this class is being recorded. So I will send us the recording as immediately I'm done. I will upload the LMS and I also make it available for you to on your group chat. I'll just send the link and you can play it.
Okay, thank you.
Please, the previous one, you cannot download it so that you'll be mindful how to do this one, sir.
Oh, you couldn't download it, but you could play it, right?
No, we couldn't.
But you're able to play it.
No.
Not play it.
It's not play. It has not played.
Really?
Yes.
Really? You could not
play it, sir.
Cannot play it, sir.
Unable to be open.
Unable to open without the passcode you have supplied, so that you change your
passcode.
You supply the passcode.
It plays to an extent and stops halfway.
You can't play. I couldn't play at all.
At all.
You couldn't play. Check your system to know if you have it.
Honestly, many people have tried for me. Maybe it's we are playing. But you can maybe change the method.
Not wrong with the system. That
if you're able to play the last
has a problem from the we could not play it, and you know it's really distressing. You are looking for something you want here and you go there with all the password.
Okay, now that I've heard it wasn't working, I'm going to download it and then upload it on the LMS so that you can watch.
Thank you very much.
Thank you,
better. Thank you, sir.
Okay, so I will download
the other one
at
this one. Yes, so until hear it and see and listen. Thank you.
Lovely. So even this, I'm going to also download this one and then you can play it. So probably areas where I was fast, you can listen to it again and again and be sure of what.
Yes, sir. We'll be grateful, sir.
Sure, I will. I'll do that.
Thank you.
You're taking my course now, so I just have to give you what you want.
Appreciate you.
Thank you, sir.
Thank you so much. So I was actually trying to explain to us system specification. If you can hear me clearly, if somebody asks you what are the requirements for system specification, probably where you're working, you are asked to go procure some computer for your organization, or you are the head nurse and you needed to buy maybe 10, 15 computers for your organization, and you're inviting the IT people to come and help you out. Prior to inviting them, you need to have some little knowledge of what systems are all about. So when you engage them, they don't just outsmart you, rather you know what you want. And once you know what you want, it will be difficult for somebody to play around you, your intelligence. And so the requirement here, the fundamental thing here is that you need to find out what is the kind of processor that the person is going to get for you, or what you need. Now, processors are actually the brain of the computer. The processor is actually seated at the middle of the motherboard. The processor is made up of what we call transistors, in other words, logic circuits. So when you talk about that device in your computer that fetch information, decode information, process and display information, all the intelligence that happen in your computer is the processor. So the processor is seated at a very strategic place of your system. What makes a system very expensive, oftentimes, and sometimes less expensive, is the processor. And processors are actually of two types at the moment, even though we have some vendors that are coming up with some types of processor. It's either Intel or it's either you're having Intel or you're having AMD. And the Intel is actually the first company that started producing processor. And then AMD came. So AMD broke out of Intel. And so when you see a computer, the first thing you find out is that, is it an Intel processor or is it an AMD processor? if it's Intel processor, the next question you ask is that, is it going to be Core i3, Core i5, Core i7? Is it dual core? These are the generation of processors we have. And then another thing also you should be careful about is when the computer itself, it's actually telling you Celeron inside. So you could see Intel and it says Celeron inside. Celeron inside is another type of Intel processor, but this one we call it the entry-level Intel processor. It's quite cheap. So you could see two computer systems of Intel, the same screen size, the same memory. If you check the RAM could be maybe 4 gig. The storage could be 1 terabyte, 1 terabyte. I mean, everything the same. But as long as one says Celeron inside, that one that says Celeron inside is half the speed of the original Intel. So it means that the price of that system are oftentimes less, almost like half of the price of the original Intel. So when you see Celeron inside, just be careful. I'm not saying it's going to go work. It's going to work, but you just imagine dividing the speed by 2. But if a particular car runs maybe 100 kilometers per hour, and then you go buy a car that runs 50 kilometers per hour, I don't think the two cars have the same efficiency. So they could have the same build, they could have the same, I mean, you enter the car, everything is looking all the same. But as long as the engine speed has a variation of 1/2 and the other half full, it means that when this man is running 100 kilometers, you are running 50 kilometers per hour. So, I mean, at the end of the day, you're not going to have a match with that person with 100 kilometers per hour. So that is what the processor is. So when it's Celeron, you expect the half the speed of the original Intel, and definitely the price will be cheap. So when you go the next time you walk into a shop and you see a laptop so cheap, check it out if it is Celeron. If it's in Celeron, just know that when you look at the speed, just divide that speed by 2. So you have a system that will just be sluggish and be looking at you, and you say, oh, we just bought this system 2 weeks ago, how come it's so sluggish like this? Just check to see if it's Intel. And the next thing you look out for is the RAM. What is the size of
What
the
about
RAM?
what about the one that has Pentium, Intel Pentium?
Yeah, well, the one that is Intel is still of Intel, so that's fine. It's not an issue. But as long as it's Celeron, then automatically off that whole cycle of the best Intel and processor you could get any day, anytime. And so when it's Intel, Pentium, fine. We don't have an issue with that. And then when it's AMD, AMD is fine. AMD is fine, but the only issue we have with AMD, though they are working on it, is that AMD overheat. And I say overheat is that it produces more heat. And when something produces more heat, the efficiency drops. You can imagine if you and I were to jog out in the morning and you're sweating, probably maybe 10 minutes into the jogging, you're already sweating and high heat coming out of your body. And me, I'm not sweating, and you could tell that you're going to stop sooner that jogging, because you will have burned a lot of energy in the process. And so when you have this AMD processor producing more heat, it means the efficiency drops quickly. And that actually tells you that it can be on the same match with an Intel processor. But another advantage of the AMD is that AMD is good with graphics. So it tells you, so it's even better off when it comes to Intel. So it all depends on what you're looking out for. Though at the moment, Intel too they've upgraded their graphics, so they have good graphics as well. But that can be a match with AMD. And then once you have taken care of the processor aspect of the system, the next thing, like I said, is the RAM. What's the size of the RAM? Is it 2 gig? Is it 1 gig? Is it 4 gig? Is it 8 gig? That's the rating of the RAM. I need to also let you know the rating of the processor. Processor is measured in heads. So you could have 1,000 heads, and after 1,000, the 1,000 is equivalent to 1 gigahertz. And so you could have a processor that is 2-point-something gigahertz. That's the way processors are rated. So you need to find out what is the speed of the processor. So you check it out, and I'm going to show us actually how you can check it on your system as well. So you could just, let me see if I could just do that quickly. That will help us so that the next time you want to get one, If you already know how to do that, that's kudos to you. So let me share this. If you can see my screen, you let me know. Can you see this?
Yes, sir.
Okay, fine.
Yes,
So
sir.
when you click on this folder down here, it brings up this. When you go to this PC, you can see this PC, right click on it, you go to properties. When you click on properties, just wait. You could see here, this is my own system now. Now, my processor is Intel, it's Core i7, and it's of 2.60 gigahertz. And it operates less of 2.5 at minimum. My installed memory is 12.0 gigabyte. And then my system type is 64-bit operating system. Now, when we talk about, I want to believe you already know what the processor is here. I want to believe you already know what the RAM is here. You see it in gigabit. You can see 11.9 gigabit usable. That means 0.1 is shared. Right now, I have my USB stick plugged to my wireless mouse. So 0.1 gig is already off in terms of memory resources that is shared. So that's why I said that resources have been shared on the laptop. So that means the more memory you have, when you begin to use certain devices or peripheral devices connected to your system, more memory will be taken from your RAM. Now, this is what we call, this is 64-bit operating system. I've explained what operating system is to us, isn't it? But then this 64-bit, the question you asked that, why 64? We have two types of operating system here. It's either 64 or 32-bit. So you need to also look at and ask, is it a 32-bit operating system or 64-bit operating system? Because even when you're going to be downloading EndNote, you're going to be downloading SPSS, you see they'll tell you 32-bit.
So it's like your screen is not showing what you are sharing. Yeah, what you are saying.
How many of us can see my screen?
I can see your screen, but what you are saying is not on the screen you are sharing.
But what we are explaining is
Yes,
not
sir.
showing. Only the PC we are seeing.
I can only see, when you say you click property, I cannot see that property. But what I'm seeing here in your screen is a desktop, documents, pictures, video, operating system, OS, data, just that. What we are saying, I can't see it on the screen,
How many of us can see the Windows 8?
No,
I can't see that.
I can't see that.
That one is on display.
Okay. So what display is the
side said where your memories are divided into three. Where you're keeping, where you're keeping.
Okay, you can see this.
Yes, that is what we can see. That's all.
Okay, great. So when you go to this PC, I said right click on the PC. Probably you can see when you just right click, it's going to give you a drop down. You could be doing this what I'm saying right now. When you scroll down, there's what we call properties. So when you right click, it will display an icon and show.
Okay, we are seeing that. Yes.
Okay, so you click on this properties. Are you hearing me?
Property. Okay. Yes, sir.
When you click
Yes.
on it, you to another page. Can you
But
see
it didn't display the page.
Okay, fine.
No page is
not
showing
seeing the page.
Okay, let me see if I can. Let me see if I can share that. Okay. Can we see this page now?
Yes.
Yes.
Now we can see the Windows 8 and everything.
Yes.
Okay.
We can see this.
Okay, fine. So when I click on the properties, this is what displayed. So when you now right click on this PC on your system and you click on properties, you're going to see this. Is that okay? Are we following?
Yes.
Yes,
So what I was
sir.
explaining initially is that I said this is where you check the system specification. And this is where you can tell exactly what you need when you're going to make a procurement for system.
This is where we can tell it.
You said? Hello?
Hi. Talking about the speed of the processor.
Yes, I was talking about processor. I said in my own case here is Core i7 and it's 2.60 gigahertz. That's the speed of my own processor.
Okay.
So this is where you know the speed of your processor. So if you see something that is less than 2 and it's maybe like 1 point something, be careful. It shows that the speed of that processor is almost like half this one. So you don't expect it to be fast. That system can never be fast. Is that okay?
Yeah.
At first, it might be fast because there are no resources.
So please, I didn't get you. When the processor is what?
What can you see on the screen? What are you seeing?
I'm seeing processor, installed memory, system type.
Is that when the processor is less 2?
Can we hear me, please?
Yes.
Yes, sir. We can hear you, sir.
I hope you guys will not drag us back and we spend the whole day here.
Sorry, sir.
But sometimes your voice diminishes.
That's why I'm saying it's being recorded. Once I'm done, you will have the recording. So that we don't go back and forth, back and forth, back and forth.
Okay.
Hello, sir.
You want us to be going back, we'll come forward, we'll go back,
No.
we'll come forward.
No, sir. Forge ahead.
So when we're done, the recording will be made available, and even on the group chat, you can post in questions, and those of us.
Okay.
Okay, just go ahead.
Thank you. Go ahead.
Are we fine?
It's okay.
Forge ahead.
Okay.
Yes, sir. Please let's mute our mics so that we'll be hearing.
So thank you very much for complying. Okay, so don't worry. Like I said, it's being recorded and the recording is on. And so at the end of the day, I'll make it available. But on your group chat, those of us who can hear me clearly, you can also interact among yourself on this. And if you're not saying it rightly, I will also try to correct you in the process. So that at least we can end this part of the computer basics well. And so I said here that the processor could be Intel or AMD, but in the case of mine here, you could see Intel, and I said it's Core i7. That means we have 3 types of core in the core family, which is the new generation processor. So there's Core i3, Core i5, and Core i7. And I say the speed of a processor is measured in hertz. So once it's 1000, it becomes gigahertz. In my own case, it's 2.60 gigahertz. And I said, if you have a system and you check and the processor is maybe 1 point something gigahertz, it means that you're actually using less of 2. And you can't really get a high speed performance of that system. And I also said installed memory in my own case as a RAM memory. You can see installed memory RAM in bracket is 12.0 gigabyte. So this is my RAM. So all my running activity like my Microsoft Word, when you put install EndNote, SPSS, and all of that, that you're using, what you're using at that point in time to run all those activities or run those applications is actually the RAM memory. And then the system type here is 64-bit. Remember when I talk about system type, we did say system types are operating system. And we said it could be Windows, it could be Mac, it could also be Linux. And we gave the different versions for each of them. In this case, mine is 64-bit. You have other systems that are 32-bit. So when you're downloading certain application like EndNote, SPSS, sometimes they will tell you, oh, 64-bit package, 32-bit package. The reason is because some systems are 32-bit operating system, some are 64-bit. When you have a 32-bit operating system, it means that your processor has 32 pathways to fetch information, decode information, and execute information. And when it is 64-bit operating system, it means that it has a 64 pathways. When I say pathways, I'm saying that as the fact that the processor is seated at the middle of the motherboard, it has 64 pathways to fetch information from the input. So when you're typing on your keyboard and you're pressing, maybe John is running, you're adding numbers, those strings of signals you're sending in, we're saying there are 64 pathways that a 64-bit operating system can pick those information. So invariably, a 64-bit operating system should be faster than a 32-bit operating system. So these are some of the things you look out for, in addition to your storage. So your storage could be 500 gig storage. It could be 1 terabyte storage. So once you can look at of the processor type, you can look at the memory, RAM memory, you can look out for the storage as a hard drive storage. I mean, you're good to go. You can as well go to sleep and be sure that you have one of the latest computer to use. So I'm going to stop on this note and give you the opportunity to ask questions. It's already 8 o'clock, and you ask question, and then we can take it up from there. And in the next class, like I said, try and install all the 3 programs we talked about, so that we can have a better class. So you have between now to the end of Sunday to do that. So by Monday, we'll be able to be on the same page. So I'm giving us this break so that we can all be on the same level. So if you have a question, you can raise your hand. You don't need to unmute yourself. Or raise your hand, and I'll ask you to ask a question. So I'm going to entertain questions from now to the next 10, 15 minutes, and after which I'll end this section. And see you guys virtually on Monday, same time. So Etefia, Andrew, are you going to ask a question, or you raised your hand long ago?
Yes, sir. Thank you so much, sir, for the lectures. It's quite interesting. Please, I want to ask, though it may not be directly what we've thought, but it's related, concerning data. Sometimes you load the data and find out that it won't be effective after some time, after some days of usage. But when you check the data balance, you still have enough. I want to understand what is going on and how we can effectively use our data. Thank you, sir.
Can you give an example of the kind of data you're referring to?
I'm talking about, like, I'm using MTN data. So when I load, maybe I load monthly, I load it monthly subscription, and I realized that it won't roll over, and the data can't open pages anymore, but in my account is still there.
That tells you that the period is higher. So when you load a new one, then you're sure to have the old one, and then you're good to go. So if you load your data and they said it's for 1 month validity, it shows that after 1 month, even though you still have some data, and please, when we're talking about data here, it's a contrasting word. The data she's referring to is the bandwidth, in other words, the download, upload when you're on the internet. So if your vendor knock you off, is because you have reached the 30 days period of usage. So even though when you still have some data left, it's what the vendor is telling you is that go and pay for more, so that you can now have the next 30 days to run. So most data subscription here in Nigeria could either be daily, weekly, or monthly. So if you choose the option, it means that after 30 days, you're bound to load another, even when you still have some data left. So they roll over immediately you do that. But if you delay and then you do it maybe when it's late after a long period, you might lost it in some cases, some of the vendors. For most vendors, you can still retain the data. I hope that's okay for you. And so I have Francisca. Any question? DK?
Yes, sir. Okay. I have a question, but please, sir, I want to make an appeal concerning the quiz. For me, I would want to have it as homework, so that we'll be able to, it will help us recall and know what we are doing. if it suits, please, sir. Then my question is, I didn't quite understand what you were saying about embedded operating system.
Okay.
If it will be possible for you, hello, sir.
Go ahead.
If it will be possible for you, yes, to just rehearse that again so that I'll be able to get one or two things, because I didn't get it at all. Thank you.
Okay. Thank you, Francisca. When we say a system is embedded, operating system, or embedded operating system, we're saying that this is a type of computer device or electronic device that has the functionality of a computer. For instance, in your hospital, you have certain machines that are not, the normal computer you have, like your laptop or desktop, but you punch in some keys, right? For instance, those in the X-ray room, they press some buttons, there's a screen, and then it displays something. That is embedded. That means there's an operating software that helps to carry out the computing part of that work. So you now have a lot of equipment today in the hospital that have some computer operating software, embedded operating software that will make it work like a computer. Is that okay? So you will say, oh, this kind of computerized system. You've heard people say this is a computerized system. But when you look at that device, it's not computer, but it's computerized in the sense that it has the functionality of a computer. You have some buttons you need to press, and you need to shut it down, you need to on it. So what we're saying is that whole package, that aid in the shutting and powering and execution, in other words, when you're using it to carry out certain hospital tests, or probably certain hospital activity, that particular functionality that you get is embedded. So it's what we call the embedded software. Is that okay?
Yes, sir. Thank you very much. I want to also know whether ultrasound is an example of this embedded.
Oh, lovely. Ultrasound is an example of embedded system.
Okay, thank you. I've gotten it now.
And there's another one we could say an embedded system. Some of you who have there's what we call a smart IoT device that takes temperature, pressure of the patient and send remotely to doctors and nurses. Those of you are interested, you can contact me on this. I can link you up, where if you have certain patients that are hypertensive and you need to monitor them remotely from their houses. So those kind of devices, we would call it embedded too, because it has the computer functionality. It can be able to work on the internet, take data, transmit data, and all of that. So that's embedded as well. So any device that you wear, that you use, it mustn't be computer, but it has the functionality to fetch data, decode data, transmit data, and display data. It's embedded. As long as it's not a computer, it's still embedded. Is that okay?
Excuse me, sir. The one we use normally, the one we use in checking for blood sugar level, is it also embedded operating system?
It's embedded. It's embedded as well. It's embedded. Okay. Thank you. So we begin to know what is embedded. So you can say, oh, it has an embedded computerized system. That's embedded operating system. So that whole display you see on your screen is embedded.
Okay.
Yeah. So thank you, everyone.
Hello, sir.
Yeah.
Sir, please, I have a question. Thank you for the lecture, sir. My question is, you said that data is a collection of raw unprocessed facts, including text, numbers, sound, images, and video. So please, I don't understand what you mean by text. Is it the text message that we do send? Then video now, sometimes when you see a video, it will give you information of what is happening. Does that video and text, are there data or information? I mean, the text message we do send.
When we said it include text, numbers, we're trying to, in the case of the data, we're saying that some of these data could be in the form of text. Some of the data could be in the form of video. That means I could have a video that just say 80. Somebody will just say, you hear a sound, an audio that says 80. And you could see a video that display and said 80. You could see a video, you could see 80 also written in a text form. That means in a word format. Is that okay?
Okay.
Are you following what I'm saying?
Yes, sir.
So when we say in the form of numbers, text, or maybe sound and video, we're saying that data can be in a text form, data can be in numbers form, data can be in audio form, data can be in video form, but in whichever form that this data appears, it won't make any sense. It means that I can just talk maybe on the phone. Maybe as I'm discussing with you guys now, you just connect and you just hear 80. The next question you ask me is, what do you mean by 80? It's not so. But that is sound you heard. You've heard 80, but 80 makes no sense to you. Am I correct?
Yes, sir.
Are you following what I'm saying? But
yes, I'm listening.
80 in an audio format, in a sound format you heard, but it still doesn't make any sense. Yes. Then you could also just see a video that just display on your screen 80. You see somebody shout 80. That's video, but that still doesn't make any sense. So what we're saying is that the computer can process in numbers, can process in text, can process in video and sound. But when the sound begins to give you more information, then that's begin to give you more, make some sense, because we say when data makes sense, it's information. So when it begins to make some sense, like they say, oh, 80 students ran away from the class. You heard such, you just heard 80 students ran away. That makes some sense. Is that okay?
Yes, sir.
So I'm saying,
so
that is when we say the sound video. So it is not a complete video of a movie you watch. It's not a complete video of a drama that took place in school, or a video of like I've finished teaching you now and you watch the video. He said video is a data. Now I've listened to a whole lecture, and how can I call this data? No. What I'm saying is that I'm saying data can be in the form of sound. Data can be in the form of text. That means data can appear in each of these forms. So that means when somebody say 80, it's still data, but this data is in a sound form. So you don't just, when you say data is just the number you write. Data can be sound, data can be video, data can be, but the question is that it will not make any sense. But when it makes sense, that's an information. I hope my explanation is clear to you.
Yes, sir. Yes, sir. Thank you, sir.
Yes, sir.
You need to wear it well so that you can understand what I'm saying. You need to put yourself in that shoe. Is that okay? Okay.
Thank you, sir.
Thank you too. So I think we're good, isn't it?
Thank you very much, sir.
Thank you,
Hello,
sir.
sir. I
God
have a
bless you.
question.
Sir, my hand is up. You didn't call me.
Oh, who is that, please?
I have a question.
Itu.
Oh, Itu, go ahead, please.
Itu,
go ahead.
Yes,
Itu,
sir.
I like the way you put your
sir,
name.
Please, when you were explaining, sir?
Go ahead, please.
Okay. Sir, please explain to me what you mean by the command line interface and GUI.
I said the command line, for example.
Hello, sir. I can't hear you, sir.
Are you still asking question?
Yeah, sir. Yes, I also have a question on operating system.
I can't hear you, sir.
You said we should differentiate between command line interface and GUI.
Please answer. Yeah, not differentiate. Just explain the two for me. I didn't understand them.
Okay, I should explain the two.
Yes, sir.
Okay. What kind of system do you use? Are you using a laptop or you're using a phone?
Answer now.
Network has locked up.
Hello, sir.
Are you using a laptop?
I'm using both. I'm using both. I'm using a laptop and a phone. Right now, I'm using a phone.
Your laptop, what kind of operating system are you using?
I'm using a Windows 7.
Good. Now, when you click on your Windows 7, I think you can,
Okay,
on your
sir.
desktop, you can see your folders, isn't it?
Yes, sir.
So you can click on your files, folders, and they have their names on them. You can open your video. That is what we
That
call
is the icons.
good icons. Those icons
Okay.
you see and click on directly without any special command is GUI. That's what we refer to as GUI.
Okay, the icons are referred to as GUI.
And yeah, how you navigate with ease.
You need the very soft one.
Yeah, that is
Who is
GUI.
making noise now? Okay.
That's the graphical user interface.
Okay.
Because it's graphics in the sense that it makes things easier for you to click, open without any stress.
Okay. Okay.
But when you need to, for instance, I promise to mute your mic, everybody, so it doesn't echo, please. Some of us will not follow instruction now. Okay. So, can you see my screen? Please mute your mic, please. Can you see my screen?
I can.
Okay, now on my screen, can you see this black screen?
Yes.
This black screen you're seeing is what we call the command line.
Okay.
So on this command line now, what I can do something here. I said ping. Are you seeing it? I'll type ping, P-I-N-G. And how did I get here? On your search, just you have on your system, you have where you search. Just type CMD on your search. It will bring this interface. CMD means command prompt. Is that okay? Are we following?
Did you say PNG?
I said
You
on your
can't hear anything.
search. You have search where
You
you
just
search.
see the screen. Can't hear anything.
Okay, if you can see my screen, if I type
from my own set up.
Can you see
PING?
See my screen? Can you see my screen?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Beautiful. If you can see my screen, this interface, are you used to this interface?
Oh, no, sir.
And that is a command line interface. So can you see the difference between this one and the one you can use?
Hello?
Can you see that this interface is different?
Can't hear any sound again.
Yes, sir. Yes, sir.
What have I
People
pressed?
should stop making noise. Oh, I don't know. Mute
How
your
would
mic.
Hey, I'm finished.
Okay. So when you mute your mic, when you said ping, for instance, you say ping www.google.com and you put a space -t, for instance, and you press enter. So if you watch my screen, you see that I'm pinging google.com. As I'm pinging google.com, is displaying and replying from Google. So that means I am checking my internet to see if I can actually use Google. This I am doing on the command prompt by typing some commands. So this is what we call the command line interface. So this is not friendly, but the GUI is what? Friendly. So this is the difference between a command line and a GUI. And I told us last time that if you want to check the speed of a network, once you ping like this, just look at the response time. In my own case, you see 141 millisecond, the time of response. So if the time of response is very high, it will start timing out. You start seeing gap. That means before it will show strings of information like this, there'll be a space. So that shows that the internet is bad. as it is now, my internet is not that bad. So the next time you search and you type CMD and you find yourself on this command line interface, you can actually ping to check the speed of your network. So this whole thing I'm trying to explain to us here is the command line interface, which is quite different from your desktop when you click on your files and folders. Okay, so I think I've answered all our questions for tonight.
Now, wow, this last one just confused me the more. I don't know how you brought the black screen to type those things you typed in. I don't know where you went to. You said search. I don't know where you put your cursor to type the search, what you were looking for before the black screen came out. I became more confused.
When you go to your computer, you usually search on your computer. It's not so. So that place where you search, just type CMD and press enter. You see that black screen. Okay, but the black screen I showed us is actually the command line. So you can see the difference between the black screen and your desktop. So you could see that the black screen almost got you confused. So that's how the command line gets people confused. And that's what the MS-DOS used to be in those days. So you can see people who were using MS-DOS those days and we now who are using graphical user interface. So I think the experience is different. So the user experience now is quite friendly and quite interactive than what we had.
Please, is the class over? I cannot hear anything again.
Yes, class is over. I'm just answering questions.
Is it from my end?
I'm answering questions. So we're going to end here, and then I'll make
What have I pressed?
I'm going to make the recording available to all of us. So
Mrs. Walker, mute your mic.
Not disturb the class. I can't hear anything again.
Mute your mic. You're disturbing us, please.
So please wait. You get the recording, and I will advise that you go through. And then if you check the elements, I'm going to upload the PowerPoint for today. And at the same time, kindly go through the zipped folder containing different chapters. Those ones, you need to study them at your convenience. But chapter 1, 2, 3 is compulsory for this course. So I want you to go through chapter 1 and 2 and 3 because I'll summarize them as well in the next class before I start the demonstration. It's compulsory in the sense that it's going to form part of your continuous assessment. So when you
I don't understand, please.
Go to the LMS. Go to the LMS and download what you have there under IT Essentials.
Okay.
And read it up. Read up chapter 1, 2, and 3.
Okay.
Before the next class. So expect my quiz as soon as possible.
Hello, sir.
Excuse me, sir. Dr. Dan.
Hello, sir.
Excuse me,
you
sir.
promised to also upload the previous class.
Yes, I did, and I'll do that.
Okay.
Excuse me, sir.
Yes, ma'am.
Is it the Tuesday? Is it just for your own quiz or with the research?
Tuesday is your exam. Tuesday is
then the quiz is when?
The quiz will be done on Monday.
Okay.
Apple?
Okay, thank you, sir.
On Monday.
So on Monday?
The Monday is quiz for his class now, not exam.
On Tuesday is your exam.
So the Monday is a quiz from your class.
Okay, the quiz from today's lecture now. Abisa?
Yes.
Okay. From today's lecture?
Yes.
From today's lecture?
Okay.
Say yes.
That's the quiz before the class on Monday.
Thank you so much, James. Quiz before the class.
Thank you so much, Mrs. Yadan.
Yeah, thank you.
Thank you, Dr. Dan.
Thank you so much.
Thank you.
Good.
Yeah, so see you guys on Monday.
Thank you.
Thank you, sir. Good night.
Thank you, sir. Thank you very much, sir.
Good night, sir.
Good night, sir.